Hello, this is Alan, starting my second video in the series on using macros in ECL, going through a worked example. Quick recap, the business scenario I've given myself is to compare attributes between two key builds on a person, where the number of attributes are so large that you can't really write ECL for each individual macro. Each individual attributes, you have to use macros. So here we have a key file, a base file, and we want that looks like has information attributes out on an individual field, and all these attributes here. And there's, where's my cursor gone? And it's a bit sticky. Anyway, there's so many that you can't really process them any other way but macros. And then there's a second day's build for the same people, and but the attributes have changed, and we want to analyze the any differences between attributes, comparing attribute upon attribute. And I've shown you what the input structure that we can work with. So we've got input data sets, but now we have to construct a new record layout from the input layout, and I've shown you what our inputs are to be able to construct, from which we can construct a new output layout. So getting on, let's just see what an output structure could be like. Okay then, so first of all we'll do this, but this 3 lines here just gets the 2 input data sets as in ready for processing, and I've already shown that how to gather the layouts for this input, these 2 input files. Now for the new layouts, we're going to construct it all in a compiler string variable, and this compiler string variable we declare, and we give it, we start it off by saying, right, we're going to call this new record layout new lay. And I've already explained in other videos what export XML does. So effectively we're loading our attributes, which is the input data structure, into another variable which we can process, string variable, and here we're looping through for each one of those fields in that input structure there. So what I've decided to do, first of all, I've got to be able to, I only really want to process the fields that contain attributes, and as I said in the previous video, I've decided that the way of detecting when I'm working with an attribute field is to anchor a regular expression to the end of field, and it's an underscore followed by 2 alphabetic characters anchored to the end of line, and that way I know I'm working with an attribute. So here at compile time, I've got the macro processor. You can run anything you like, ECL, to compile time. So here I'm just using regex find to give me a Boolean result, yes or it isn't, yes it's an attribute field, or no it isn't. If it is an attribute field, then I'm going to put both, I'm going to construct, I'm going to keep the base data's attribute, I'm going to keep the candidate's attribute, and I'm going to give calculate a percent change and associate that with each attribute. If it's not a attribute field, so if it's, let's say, first name or anything like that, then I basically just pass it through to as is into the new layout, and at the end I just terminate, make sure that the string, the record layout is terminated. And so I can do this, as I said, the syntax for outputting a string or making a symbol variable a string is this format. So if I print that out, that will generate the new layout as a string. So it's very easy for compile to dump out and see what you're doing with compile time strings. And you just have to do a, notice I don't need a semicolon at the end there, because I've got a semicolon inside the append there, so I've done things that way. So let's just submit that. I can submit it on H4 because it's such a simple task. Let's see what's it doing. Shouldn't take any time at all. Hey, and there we go, and that's the layout, the target layout for my analysis. Let's copy that to TextPad and have a quick look at it. There we go, and it's all decimal base 10, so things which aren't attributes, it's detected and just pass them through. But for every attribute now, I can record the base value, I can record the candidate value, and I can record a % change for every attribute there. So that's what I've generated with that code there, and I've called it new lay. A little thing to notice here, that really I've hard coded in here decimal 10.2, but really if at all possible you should use what the compiler gives you. So there's an attribute to the field as you know, XPath format, ECL type, which gives you the type of that particular field. So if I just show you that in here we go. So here we are, we've got ECL type there, string 18, or let's look at an attribute here. ECL type is decimal 10.2. There is an underlying type, well, there's type, which gives you a base type to the field, but really what we wanted was ECL type. But I just wanted to show you, demo both, that effectively those two are equivalent there. And I think, so then to move on, we want to populate this new structure with the data from the two inputs here. So that's the structure we're targeting for. Now this should actually, this extra bit of code here is actually doing the job of generating a data set with these with the new structure. So firstly, I'm using new layout, and new layouts, remember, generates a record structure called new lay, and it's actually putting it into a token stream. So it's actually generating the record structure at this point, not actually printing it out as a string there. So that will declare new lay for us. Now what actually does the job, why is it so sticky? I don't know. Anyway, so the job is to join let's join the base data set to the candidate data set, which we've defined above, and because it's so sticky I can't be bothered to show you there. So we've got our two input data sets. We can join them on the key to the personal data, which is rec ID, and we can do that all locally because we've distributed both by rec ID there. And the transform is where the magic's done, and we just pass the base record on the left hand side, the candidate record, every candidate record that matches it on the right hand side. And here we just so this is the transform. Its output is obviously this new layout, and the input is two records with the input layout. And again, I do the same regex as I was doing above to detect an attribute field. So if I've got an attribute field, then I can generate the base value, which is just the left hand side, candidate value is just the right hand side, and percentage change is a calculation cast into decimal 10.2 here, and you can see it's all enclosed. See those brackets in green there, and that's a calculation that's just a right minus a left divided by the absolute value of the original value, the left, the base value, times 100 there. Again, if it's not a attribute field, I just assign the value to the left hand side. They'll be identical anyway because the key value is the same, so it's the same person, so I can just do that simple assignment there. Now in real life, perhaps what would happen is I've made this a result here, but this really is an intermediate result which would then go on for further processing, because it's all very interesting having this, but you know, you still haven't been alerted. The actual job is to detect and alert people if something's gone awry between two builds, and this hasn't done any alert. This is prepared you to allow you to find differences, but isn't actually alerting you. So this usually would be an intermediate result, but because I'm doing a training video and splitting it up into different sessions, I made this a final result. So here I'm outputting it to a new data set here so we can look at it. Few things to notice here. I think I'll do them in gotchas. This it's very difficult. I said that you can always trace out compile time variables here, but by putting quotes in them, as you saw in the previous video. But when you're dealing with insertion into the token stream or inserting into the lexical analyzer part of the ECL compiler, which then generates a token stream, use expand, and there's no way to trace out the ECL that you're attempting to generate. So this can make debugging and getting these working really quite difficult. So you can spend 2 hours or half a day just working out where a semicolon is missing or not, as the case may be. I find it handy to when I'm writing these expand constructs, is to actually write out the target ECL I'm trying to create as a comment above, and actually leave that comment in the code, because it'll be handy for people you know that take on this code. That's a very useful kind of comment to have up there as well. So let's just run this. I have to run it on 4 because I'm generating a data set here, and let's just execute this and see what we get. We'll have a look at while this is running, we'll have a look at the graph so we can understand what's going on here. I do a quick sort as well, just to make it easier to read really at the end. Not strictly necessary. Right, so let's look at the graphs. It's always handy to get an understanding of work units from graphs. There's an awful lot of debug information presented to you, and it's a shame not to use it, really. You get a good feel of how your work unit's running, and you can start thinking, oh, optimizations, and you can spend your more time looking at graphs than actually writing ECL. Oh, it seems very sticky. I don't know what's going on. Anyway, right, so graphs here. So we can see, first of all, it is in the executing phase. Very simple graph, only one of them. Come on. I'm going to run out of my YouTube time, 15-minute time limit, just waiting for these things to come up. I wasn't doing this yesterday. Ugh. Right, so let's where we're going here. Right, so how many were there? So it's already completed the hash distributes, because if I look at logical files, the input size is 814,400. So it's now doing the join, and it's done about, well, it will have done half of the join now. But there's all sorts of information you get with this. So one of them is the line number of the ECL. Oh, it's completed already. Oh gosh. But anyway, if I could just, it's so sticky, it's actually quite difficult to show you things. But in here, one of the things you'll see is the line number is actually off. Oh, there we go. So definition list 144, and if I actually go to 144, you'll find that actually is the joins on line 144. So it's generated the output. Let's see what it's done. Oh, there you are, it actually has done it. Same number of records, but obviously a lot bigger. And if we have a quick look at that, contents, go. Won't waste time doing all that because it's taking so long. It's the other data, and here, if it finally gets around to rendering it for me, come on, oh, this is painful. There you are. For every candidate, we've got a base value being populated. We've got a candidate value for the candidate's key file that we're analysing, and we're getting the percentage change from yesterday to today, or between the two key files here, and that is there for every. I'm not going to scroll around because it's so sticky, but take my word for it, this has been done for absolutely every attribute here. And so, as I said, this is, I've decided to make this an intermediate result so we can move on to another video, because at the moment it hasn't actually alerted, or it's generated the data for us, but now we need to probe this data and start throwing alerts or writing out reports on what we found here in this file. So I'll see you in the third and final video. Cheers, bye.